In this lesson, we're going to learn how to graph a linear inequality, or when we have two of them, we'll learn how to graph a system of linear inequalities. Let's go through the steps. First off, we'll graph each inequality as if it were an equation, but we'll have to follow the following rules. We'll use filled dots and solid lines if our inequality symbol is either the less than or equal to or the greater than or equal to symbol. So if you see a little line underneath representing the or equals to, that should help you remember to use solid lines. And if it's on the line, because that's what a solid line means, you're going to want to use filled dots. On the other hand, go ahead and use hollow dots and dotted lines if the inequality is simply less than or greater than. When it comes to the shading part, you're going to have to select a point that is not on the line. And I put line in quotes because really it's an inequality and the line may or may not be included. But the point is, pick a point that's not going to fall on that line and then substitute the values into the inequality. If it's true, you're going to want to shade the side that contains the point. If it ends up being false, then don't shade that side. And what we'll eventually find out is that you'll end up shading the other side that would not contain the point. Finally, when we get to the part where we're going to graph a system of linear equalities, the actual solution to that system is where the shaded regions will overlap. But that will be our fifth example. We have a few just linear inequalities to look at first. Our first example is y is less than negative 3/4 x plus 2. Because of the less than symbol, we will begin forming our line by using hollow points to help us set up the line, and then when we come to actually drawing the line, we'll use a dotted line. A dotted line when it comes to inequalities means that the solution goes up to but does not actually include the line itself. And that's why I've also chose to draw our line out with hollow points, because what did hollow points mean on a number line? It meant it went up to but not including it. So let's be consistent here. So when I figured out my y-intercept, because that's my value of b in this slope-intercept form, I immediately was able to graph 0, 2, and you'll just see now I'm just going to draw that now with a hollow point. As I figure out my other points, because of the slope, negative 3/4, meaning down 3 and right 4, so I went down 3 over 4, down 3 over 4, and then I did everything backwards, so I went up 3, back 4, up 3, back 4, and then I can draw my dotted line. Now I have determined where sort of the fence is of this particular inequality. So when it comes to determining what side of the line I'm going to be shading, I need to choose a point that's not going to actually be on the line, because if it was on the line, it doesn't really tell me anything. So think of the line as a fence. You need to be off the fence. I chose 0, 1. That's going to represent all the points. That would represent 0, 0, 1, 0, 2, 0. It could represent 3, negative 1. It could represent even this one right here, negative 3, 4. All these points are going to be represented by here. If this ends up being true, which it is, because I took its x-coordinate, 0, plugged it into the x of the inequality, took its y-coordinate, 1, plugged it into the y spot of the inequality, did the math, came up with 1 is less than 2, realized that isn't always going to be a true statement, which means any point over here on this side will always be true. This is the side that I'm going to shade, and this will eventually be my solution. But as we're starting out, we do want you to kind of test out both sides. So I then proceeded to choose a different point on the other side, 0, 3. As you can see, if I plug the 0 and the 3 into those spots, eventually we'll get 3 is less than 2, which is a false statement. And because it's false, not only this point, but all the points on this side are not going to work. So we do not want to shade this side. So our final solution is, ta-da, the side with the point 0, 1. Let's do this again. 3x minus y is greater than 6. Because it's greater than, hollow points, dotted line. For this problem, because it is a standard form, I decided to go ahead and find my x-intercept. Remember, if I'm finding my x-intercept, I'm just going to make y equal to 0, and that will drop this piece out, making this 3x equal to 6. I solve for x, I get 2, so one of my points is 2, 0. When finding my y-intercept, that's because my x is equal to 0. So I just drop this part out, I get negative y equal to 6. When I multiply both sides by negative 1, I get y equal to negative 6. I get this point here. This is enough to establish 2 points, which of course leads to the ability of me figuring out slope. Because if I go up 6 and over 2, It is the same as going up 3 and over 1. And so I'll continue to do that, and now I'll draw my dotted line through those particular points. So now it came time for me to select a point not on this particular line. I chose the point 2, 4. I plugged 2, 4 in, so I went 3 times 2 minus 4. That produced 6 minus 4, which is 2. Well, 2 is not greater than 6. This is false, so everything on this side should not be shaded. Let's go click, let's say 4, 2. Now if I go 3 times 4 minus 2, that's 12 minus 2, which is 10. 10 is greater than 6, so not only will this point work, but all these points over here will work as well. So that's why I shaded this side, and that's what makes this side the solution to our inequality. Third example. 5x plus 2y is greater than or equal to negative 5. Now we have a greater than, and more specifically, or equal to symbol. That means filled points. These points will be included. That's why we say it's a solid line. Every point that's on here is going to be included. Now, I decided to also do, because it's a standard form, do my x-intercepts and y-intercepts. I had no problem with the x-intercept. 5x equaling negative 5 means I get x equals negative 1, and I get a very nice point. But if I put 0 into here and I get 2y is greater than or equal to negative 5, I do get y equal to negative 5 halves. Now, with a computer system, it's easy to graph because it will graph it accurately. If I'm doing this by hand, I wouldn't trust that. So even though this point's here, that's not what I would be using to base the rest of my line on. So what I did is I decided to take my standard form and change it to a slope-intercept form. So once I move the 5x over to the other side by going negative 5x minus 5, and then I divide everything by 2, and yes, I just use as an equal sign. I'm just trying to get the idea of what my slope is. I realize my slope is negative 5 halves, which means let's go down 5 and over 2. And when I plot that point and then connect this point to that one, it will pass very nicely through my original 0, negative 5 halves. Of course, I could go up 5 and back 2 to make sure that I have a more accurate graph. I'll connect the dots, but this time I'll draw a solid line because the solid line, again, means it's part of the solution. So all these points will also work here. You still have to go pick points on opposite sides. So in this case, what I chose is negative 3, 0. Because if I plug negative 3 into here, that's negative 15. I plug 0 into here, that's 0. And negative 15 is not greater than negative 5. That is a false statement. So let's move over to the other side. In this case, I chose 3, 0. 15 plus 0 is greater than or equal to negative 5. I shaded this side, which means these points all work, and that is how we come up with our solution for 5x plus 2y is greater than or equal to negative 5. One more inequality before we get to systems. Y is greater than 1/3 x. Well, we got hollow points, we have a dotted line. In this particular situation, I do have a y-intercept, even though I don't see it. Because that could still be considered slope-intercept form, I could think of that as plus 0. And so because it's plus 0, my y-intercept is equal to 0, and I could draw the point 0, 0. Remember, I'm using a hollow point because that point will not be part of the actual solution. But then I have the slope right here, 1/3. So I can go up 1 and over 3, up 1 over 3, then connect my dots with a dotted line. Now I need to determine what side to shade. Let's start with the point 0, 1. I plug it in, 1 is greater than 0. This is true. I will shade this side, meaning all these points should work. And then I chose, well, 1, 0. In this case, 0 is not greater than 1/3. I chose none of these points over here to shade, so that's why the top part is the solution to y is greater than 1/3 x. This brings us to the end of our single linear inequalities. Now we're going to move on to system of linear equalities, where we have 2 inequalities. For instance, our first example, y is less than or equal to 4, and x is greater than negative 2. For these particular problems, I'm going to keep the inequalities on separate sides along with their work just to be better organized. And we'll start by graphing y is less than or equal to 4. We know that being less than or equal to means we have filled points and we'll need a solid line. Because y equal 4 is a horizontal line, which has, of course, 0 slope, you just have to remember that means all the y coordinates will equal 4, so when we go ahead and graph that, that's what it's going to look like. We're still going to go ahead and pick one of 2 sides. Now, in this case, I'm going to keep going back to 0, 0. The reason I like to choose 0, 0 is because it's an easy point to work with. So why not use it whenever possible? If I put 0, 0 into here, 0 is less than 4, this is true. So I'm going to shade the side with point 0, 0. At this point, I think it's pretty clear that we don't have to then do the other side to find out it's going to be false. So I'm going to pick one side. If it's true, we're done on that side. If it's false, we're just not going to shade the side with that point. We'll just shade the other side, and we'll be done. So that's why we can move right away to graphing x is greater than -2. Because this has hollow points, being that it is greater than, and we'll need a dotted line. We'll graph that dotted line with all these points because it's a vertical line. It's got undefined slope, and all the x-coordinates are -2, so there it is. There's our graph. Let's go ahead and pick 0, 0 again because that point happens not to be on there. If I go 0 is greater than -2, that's a true statement. So, yep, we're going to shade the side with 0, 0. So if we look at the two graphs being overlapped, you have this side being the x is greater than -2, the bottom part here being y is less than or equal to -4. The purple region is the solution to our problem, and that's what we're going to say. The solution is where the two regions overlap, and that's what we're going to graph there. We'll move to our second example of a system of linear inequalities, with the first inequality being y is greater than or equal to -3x plus 1, and our second inequality being x minus y is greater than or equal to 5. On the left side, we see that y greater than or equal to -3x plus 1 means filled point solid line because of the or equals to. We also see it's a slope-intercept form. We can establish then our first point, being our y-intercept, is at 1, or specifically 0, 1. We'll take it now a step further once we realize that our slope is -3, which could be written as -3/1. So down 3, right 1 we go for all our additional points. Let's connect the dots, and now we'll need to choose a side. Guess what point is not on the line? That's right, 0, 0. So that's what I'm going to choose. Except this time when I plug 0 in for y and 0 for x, I'm going to get 0 is greater than or equal to 1. This is a false statement. So if this point does not work, then this whole left side is not going to be part of the solution, which by then default means the right side is going to be, and so why not just shade that right away over here. Let's go do the x minus y is greater than or equal to 5. That is a standard form, which means, now besides being filled points in a solid line, we can find the x and the y intercepts. Cover up the -y, you get x equals 5, or 5, 0. Cover up the x, you get -y equal to 5. Well, multiply both sides by -1 and you get 0, -5. That's enough to establish a slope of up 5 over 5, but that also can be reduced as up 1, right 1, up 1, right 1, and so on until we get there. And what you find out is when we connect the dots, we're going to have this particular line, and now we're going to have to pick a point. Oh, looky here, 0, 0 still works as a possible point. So let's go plug in 0, 0. 0 minus 0 is 0. That is not greater than or equal to 5. So once again, 0, 0 is the side we do not want to shade. We'll want to shade the other side down here. So as we take the two graphs and see where they overlap, our solution area again is where these two regions overlap, the purple section, and so this is where I would establish my solution to be. Our third example is 2x plus y is less than 0, x plus 4y is less than or equal to 0. Our first one's going to be consisting of hollow points and the dotted line because of this being less than and only that. We have an x-intercept, we have a y-intercept. In both cases, they're both going to end up equaling 0, so I'm going to get a single point. If I had two separate points, wouldn't be an issue, but because they're the same x and y-intercept, I'm probably going to need to go to, let's say, slope-intercept form. So let's move the 2x over to the other side, y equals -2x, and then establish that our slope must have been -2, which means -2 over 1. So down 2 and to the right 1, down 2 and to the right 1, down 2 to the right 1, and so on. Now that I've graphed the dotted line, let's go plug in my favorite point 0, 0 into the inequality. But realize, actually, I can't do that because it's actually on the line. Remember, if you're going to determine what side to shade, you need to pick a point that's not on the line, and 0, 0 is right there on it. So I had to make a different choice, and I chose 1, 1, because it's pretty easy. 2 times 1 plus 1 works out to be 3. And 3 is not less than 0, so because it's a false side, no shading on this side, I'll shade this bottom left side. Let's go do something similar over here with the x plus 4y is less than or equal to 0. Realize, except this time, I will use filled points in a solid line. But I do run into the same issue when I do the standard form trick, finding my x-intercepts and y-intercepts. In both cases, I again come up with one single point, 0, 0. 0 being the x-intercept, 0 being the y-intercept. So I guess I'll have to convert this back to slope-intercept form. So let's move the x over to the other side, 4y equals negative x. Divide both sides by 4, and you'll come up with negative 1/4 for a slope. So down 1 over 4, down 1 over 4 I go. We'll draw our dotted line and realize I can't use 0, 0 again because, again, it's on the line. So I went back to 1, 1. 1 plus 4 times 1 is 5. 5 is not less than 0. Did not shade this side, therefore I shaded the bottom left again. Now we'll take our red region, which represents the second inequality, place it on top of our blue region, which represents our first inequality, look at the purple section, which is where the regions overlap, and realize that's our solution to this particular system, right there. Finally, we come to y is less than 1/2 x plus 6, and x minus 2y is less than negative 2. Both of them are going to be hollow points with dotted lines. We can find the y-intercept just by realizing the slope-intercept form of 6 puts us there, and with the slope of 1/2 moving us up 1 and over 2 each time, we can then draw our dotted line. We'll select 0, 0 because we do have that option again. We'll find that 0 placed into that spot there, and 0 placed in there means 0 is less than 6. That's true, so we will shade this side. Since my second inequality is in standard form, I will use my x and y intercepts to help graph the line. I'll plug in 0 for the y here and come up with x is equal to negative 2 and come up with the point negative 2 comma 0. For my y-intercept, I'll plug 0 into the x spot, have negative 2y equal to negative 2. Let's divide both sides by negative 1 and come up with y equals 1. With those 2 points, I can realize that my slope is going up 1, right 2, up 1, right 2, up 1, right 2, for a slope of 1/2. And when I draw the dotted line, since this was also, for the first inequality, up 1, right 2, I have 2 parallel lines. That still doesn't prevent me from using 0, 0 as my point to determine the shading. If I plug in 0, 0, 0 minus 0 is not less than negative 2, so I will not shade the side, I will shade above the dotted line. So where is the overlap between the red and the blue sections? Right here, this purple region. So it's a little different than what we've seen in the past. It happens to be, this area happens to be our solution to our final system of linear inequalities.